That's galvanic corrosion. Where does it really come into play? We spoke earlier about bulk corrosion and how steel in seawater is not really a good thing because the chlorine. We talked about zinc oxide. Let's say if it's in a ocean, you might be making iron chloride with the salt. And that also forms a corrosion product, not an oxide, and that corrosion product falls off. How do you stop your ship that's worth about $1 billion, that's a billion with a B, if it's a tanker, from corroding because it's got to sail around the world? This is what they do if you have a look over here. We'll just throw the video across and I'll just talk off the computer so I'm off screen. That is a zinc anode that is bolted to the hull of a ship. So that zinc anode there, that's bolted on. There's your electrical contact. You've got steel hull, zinc anode, electrical contact. When it's underwater, you've got a means for the ions to transfer. And the zinc corrodes preferentially to the boat. And then you just send your divers down every 6 months or a year with extra zinc anodes and they just replace the anode. It's a lot easier to pay a diver $20 an hour or $40 an hour than it is to pay a insurance company $1.6 billion. So that's the common way that boats are protected. I'll just go through a few more photos I've downloaded here. That's what they look like before. This is an after shot. The zinc corrodes, but you'll notice the steel around it has not really corroded at all. And you can even see here where the flow of water is going from right to left around the anode. You can even see where it's scrubbed out and you've still got raw iron, uncorroded iron sitting on the surface. They use the anodes as well on oil rigs. You can see the zinc anodes all over the oil rig structure doing the same thing. Every time there's sea spray, that saves the oil rig from rusting on corroding and falling in, and just means they've just got to replace the anodes on the oil rig. Once again, anodes all over the back end of a boat. Incredibly critical, especially where the propeller goes in, because the propeller is copper or brass. If you remember the table, monkeys and zebras in the loo can't copper. The copper-based alloys are incredibly non-reactive, which means the iron starts to corrode around the copper. You've really got to make sure that you keep this iron where that propeller shaft is running through the boat intact. So there's a lot of zinc around the back end of a boat for exactly that reason. Once again, more anodes, and I think that's it.